Okay, so we are discussing the S matrix for the quantum electrodynamics, and then in the last lecture we were looking at the second order term in the expansion, and then we were seeing which term in the S matrix can contribute to what physical process. Especially we were looking at this term that I have denoted it as S22, which is given by minus E square d4 x1 d4 x2 normal order product of psi bar x1 A slash psi x1 psi bar x2 A slash x2 psi x2, where psi of x1 is contracted to psi bar of x2. Now, this contraction here indicates that there is a virtual fermion which propagates from x1 to x2, and then there will be one fermion, there will be two fermion and two photons in the initial and final processes. So, this indicates that the physical processes that can give a non-zero contribution from this term in the S matrix are the following. You can have the Compton scattering gamma plus E minus, you can have the analogous of Compton scattering with positron which gives gamma plus E plus, you can have pair creation or pair annihilation. So, gamma plus gamma going to gamma E plus plus E minus, E plus plus E minus going to gamma plus gamma. So, let us try to understand the Compton scattering and then what is the term in the S matrix that gives non-zero contribution to the Compton scattering. Here this basically says that there is an incoming photon and an incoming electron, and there is an outgoing photon and outgoing electron. So, outgoing photon and outgoing electron basically indicates that it should contain A plus of x1 or A plus of x2 for the outgoing photon. For the outgoing electron, it should contain psi bar minus of x1 and for the incoming photon you have this will destroy a photon, right. So, you need A1 A minus of x1 or A minus of x2. For this one you can have A plus of x1, A plus of x2, and you can have psi plus of x2. Okay. Psi bar of x1 will have two terms, psi bar equal to psi bar plus psi bar minus. Psi bar plus represents the annihilation of a positron, whereas psi bar minus represents the creation of an electron. So, the only term here that can contribute to this process is psi bar minus, whereas psi which is psi plus plus psi minus. Psi plus indicates annihilation of an electron. So, this, whereas psi minus represents creation of a positron. So, for this process only psi plus will be present. So, what we can have is the following. For this process, this S matrix should contain psi plus of x2, a plus of x1, okay, and then psi bar minus of x1 and a minus of x2. Either it should contain this pair, or it can also contain psi plus of x2, a plus of x2, okay, then psi bar minus of x1, a minus of x1, right. It cannot contain both a plus of x1 and a plus of x2, because that will not give a finite contribution to this process. So, there are only these two possibilities. Is there any other possibility that can give a non-zero contribution to this process? You can inspect quickly and then you can conclude that no other possibility is there. So, you can either have this set of operators, or you can have this set of operators in the S matrix. So, I will write, therefore, accordingly there will be two terms. This one I will call SA, which is minus E square d4x1 d4x2 normal order product of psi bar minus of x2 gamma alpha a psi bar minus of x1 gamma alpha a alpha plus x1 this propagator, and then gamma beta a beta minus of x2 psi plus of x2. Okay. Whereas, when this set of fields are there, what you will have is, I will call this as SB, which is minus E square d4x1 d4x2 normal order product of psi bar minus of x1 gamma alpha a alpha minus of x1 psi of x1 psi bar of x2 contraction gamma beta a beta plus of x2 psi plus of x2. and the amplitude for this process will be S equal to the sum of these two terms, SA plus SB. In other words, if you write psi bar equal to psi bar plus psi bar minus and so on, this term will give many terms. However, if you evaluate the matrix element of this quantity for this process, E plus E minus plus gamma going to E minus plus gamma, then these are the only two terms which will give you non-zero contributions. Let us pictorially represent both these terms. This term SA here, I can write it as some incoming electron which is annihilated at x2 and then there is a photon gamma, then there is a fermion propagating from x2 to x1, and then you have an outgoing electron E minus with a photon which is getting absorbed at x1. So let us look at A plus of x2 so A plus of x1 here, for example, indicates annihilation of a photon at this space time point x1. So you have correspondingly an incoming photon at x1 which is getting annihilated, whereas there is an A minus of x2 which represents creation of a photon at x2. So therefore there is an outgoing photon at this space time point x2. Similarly, you have psi plus of x2 which indicates annihilation of an electron at x2. So you have an incoming electron which is getting annihilated at x2, whereas psi bar minus of x1 indicates creation of an electron at x1. So you have an outgoing electron which is getting created at x1, and then there is a propagator psi x1 psi bar x2 which describes propagation of an electron from x2 to x1. So pictorially I can represent this term of the S matrix like this. What about this term here? So this term again says that you have psi plus of x2, which means that there is an incoming electron which is annihilated at x2, and then A plus of x2. So there is an incoming photon which is getting annihilated at x2, and then it also contains psi bar minus of x1. So at x1 there is an outgoing electron which is getting created, and A alpha minus x1 basically says that there is a photon which is created at x1. So what I did is I represented this incoming electron with an arrow, with a straight line with an arrow, and the propagator again I represented it as an arrow, and outgoing electron is again a straight line with an outward arrow. Whereas for the photon I represent it as a curly line, just to make a distinction between electron and photon. So photons are represented by curly lines, whereas the electrons are represented by straight lines with an arrow. Okay. So these kinds of pictorial representation for a physical process which gives a contribution to the S matrix are known as the Fineman diagram. So what I have drawn here for you is the Fineman diagram for the lowest order for the process gamma going to E, gamma plus E minus going to gamma plus E minus. So these are the Fineman diagrams for Compton scattering in the lowest order. Correspondingly, if somebody gives you a diagram, okay, so given a physical process, you can think of how to pictorially represent this process, and then given this diagram you can surely write down what element of the S matrix will give you a non-zero contribution for this process. Now it is straightforward from whatever we have analyzed till now. If I give you this picture here, then you can write down, of course, this S matrix element, and similarly this one here correspond to this S matrix. So you consider this process, you know that at lowest order these are the only two possibilities. So you draw these two diagrams and then you write the corresponding amplitudes and then you add them. So this will give you the amplitude for the full amplitude for this physical process, gamma plus E minus going to gamma plus E minus. All right. Okay, so this is just one such term here, which describes this process of Compton scattering. Similarly, you can discuss about pair creation, pair annihilation, and so on. Let's see how can we what happens when we want to describe this process of pair creation. So suppose you want to describe this physical process gamma gamma going to E plus plus E minus. So what do you expect from this S matrix element here? What are the terms it should contain? It should, of course, there are two incoming photons, so you should expect A plus of x2 and A plus of x1. It should contain A plus x1 and A plus x2, whereas there is this E, there is a outgoing electron and there is an outgoing positron. So what do you have for outgoing positron? So for outgoing positron and outgoing electron, you have psi minus and psi minus of x1, psi bar minus of x1 and psi minus of x2. So it should contain this combination of operators, definitely. Is there any other combination of operators that is possible for this process? You can see and conclude that there is no other combination which is possible for this process. So this part of the S matrix S2 to gamma plus gamma going to E plus plus E minus, which basically means that the term in the S matrix which gives a non-zero contribution for this process, that term must look like integration d4 x1 d4 x2 and normal order product of psi bar minus of x1 a slash of x, not a slash, gamma alpha A alpha plus of x1, then psi x1 psi bar x2, and gamma beta A beta plus of x2, then psi minus of x2. So, this is the term in the S matrix that will give non-zero contribution to this process. Pictorially we can again represent this. So, there is an so you see there is a outgoing electron which is created at x1. So, this must be the space time point x1 from which an electron is getting created. There is a fermion which propagates from x1 to x2 or x2 to x1, and there is an incoming photon which is getting annihilated at x1. There is an incoming photon which is getting annihilated at x2, and this term basically says that there is an outgoing positron which is created at x2. Okay. So, therefore, the corresponding diagram looks like that. You may notice that although there is an outgoing positron here, I have drawn this arrow inwards. This is just to make consistent, so that this arrow has a one direction. So, whenever there is an outgoing electron, I will draw it as a straight line with an outgoing arrow, but whenever there is an outgoing positron, I will represent it with a straight line with an incoming arrow. Similarly, if there is an incoming electron, I will represent it with a straight line with an incoming arrow, whereas if there is an incoming positron, I will represent it with a straight line with an outgoing arrow. Okay, that way I can you can see that in this diagram, this arrow is directed along one direction only. Two arrows never approach each other and meet at a single point. Okay. So, this is the Fineman diagram for this process, and this is the element of S matrix that gives you a non-vanishing contribution for this process. So, okay, so you can consider other physical processes for arising from this term in the S matrix, and then you can similarly write down what is the which term in this S matrix gives a non-zero contribution. What we will do is, we have other terms that that we got from the weak expansion. So, we will discuss them and then see what are the physical processes we can understand from those terms. So, let's discuss, let's look at this term which I represent it as S23. This is given by minus E square over 2 d4 x1 d4 x2 normal order product of psi bar x1 gamma alpha A alpha of x1 psi bar x2 gamma beta a beta of x2 psi of x2 with normal ordering. So, you can note with this term contracted to this term. You can notice that there is a psi of x1 here. Good. So, you note that here the photons are contracted with each other. So, there is a photon propagator, and hence there are no free mu fields inside the normal ordering. Therefore, this represents that there is no incoming photon or outgoing photon at all. There are only incoming electrons and positrons and outgoing electrons and positrons possible. So therefore, there are these physical processes which will give, for which this will give non-zero contribution. The processes are E minus plus E minus going to E minus plus E minus, which goes with the name of molar scattering. There is also this process which is called as the Wawa scattering, which is scattering between electron and positron, and there is this positron analogous for the molar scattering, which says that E plus plus E plus going to E plus plus E plus. So, these are the processes that can be understood from this term in the S matrix. Let us try to understand the electron scattering. Okay. So for electron scattering, what do you expect? What are the terms in the S matrix that should be there? You should have incoming electrons, so 2 incoming electron and 2 outgoing electrons. So you have psi bar minus of x1, psi bar minus of x2, and psi plus of x1, psi plus of x2. Okay. Psi plus x1 and psi plus x2 will destroy an electron at x1 and x2 respectively. So whereas psi bar minus x1 and psi bar minus x2 will create electrons at x1 and x2 respectively. So pictorially you have an incoming electron which is destroyed here because of the presence of psi plus x1, and there is an outgoing electron which is created here because of psi bar minus x1. There is a photon propagator between x1 and x2. So you have a virtual photon propagating from x1 to x2. This is a gamma, and then you can see that there is a incoming electron which is getting annihilated at x2, psi plus of x2, E minus, and E minus. So this is how it should look. Okay. What so therefore this is we can write down the S matrix that gives you non-zero contribution to this process. So S2 3 E minus plus E minus going to E minus plus E minus is given by minus E square over 2 d4 x1 d4 x2 psi bar minus of x1 gamma alpha psi plus of x1 psi bar minus of x2 gamma beta psi plus of x2 with normal ordering, and then A alpha x1 A beta x2 contracted. Okay, because this is a C number, I can take it outside the normal ordering, and this is what I get. This is the term which gives you contribution to the S matrix. Now, there is something very important for this in this process that we need to discuss in more detail. You know, the incoming electrons E minus plus E minus going to E minus plus E minus, they are identical particles. So an exchange interaction can take place between them, and then we need to understand how to compute the amplitude for this process, taking care of the exchange interaction. So let us understand this process here. Let us say this is electron 1 and this is electron 2. So electron 1 and 2 going to electron 1 prime and 2 prime. Instead of specifying their momentum and spin, etc., I am just saying that I am just representing them by 1 and 2, 1 prime and 2 prime respectively. So what is the in state? The in state is basically C dagger 2, C dagger 1 acting on the vacuum, whereas the out state, which I will call as F, is C dagger 2 prime, C dagger 1 prime acting on the vacuum. Okay. So if you want to evaluate, if you want to take this term here and then you look at the matrix element of this term for this process S2 3, then what are the terms that you expect? First of all, it will contain, you can write it in terms of their Fourier components, okay, and then it will contain a bunch of p integrations and so on, and then you have gamma alpha and all those things. We will not worry integration over d4x1, d4x2, let us not worry them for a moment. What you will have is, you will have in between this, you have 4 operators which I will denote as 2 creation and 2 annihilation operators. Because of the normal ordering, they will be ordered like this: C dagger K1, C dagger K2, C P1, C P2, and then there will be a bunch of terms which I will not worry for the time being. So this is what you will have, this, and then other terms will be there in the matrix element. So what do you get from these terms here? Now because of this term, the presence of this term here, as you can see, it will give a non-zero contribution if P1 equal to 2, P2 equal to 1, or it can give a non-zero contribution when P1 is 1, P2 equal to 2, right. Similarly, you can look at this part here, and again you will have a non-zero contribution if K1 is 2 prime, K2 is 1 prime, or if K1 is 1 prime, K2 is 2 prime. So therefore, when you evaluate it in more detail, which we will do later on, what you will get is, you will get 4 terms here, okay, However, you note that there is this integration over d4 x1 d4 x2. So when you change the variable x1 to x2, you will see that out of these 4 terms, 2 of them will be equal to each other. So there will be 2 remaining terms here. So I will let's say that 1 2. So the 2 remaining terms, which I will call them p1 going to 1, p2 going to 2, and then this. Okay. So then let's assume that it's already taken care of. So therefore you have this option where k1 will be equal to 2 prime and k2 will be equal to 1 prime with this, or you have k1 going to 1 prime and k2 going to 2 prime with this. These are the 2 terms here which are possible. So what you can do is you have correspondingly 2 diagram here. So there is an incoming electron which I will call as 1, and this incoming electron which I will denote it as 2. So 1 2 going to 1 prime 2 prime, there is a photon propagator, or you have this possibility here, 1 going to 2 prime 2 going to 1 prime, and there is a photon propagator, and the amplitude will be sum of these 2 amplitudes. What you need to keep in mind is that there is a relative minus sign here, because you look at this process here. What is this f? C dagger k1 C dagger k2 is nothing but this C1 prime C2 prime and then C dagger k1 C dagger k2. So therefore, if 2 equal to 1 prime, so whatever contribution it will give for this process when k1 is equal to 2 prime and k2 equal to 1 prime, because these operators anti-commute, if you consider this process where k1 is 1 prime and k2 is 2 prime, then this operator needs to move this side, and then you consider the anti-commutation. So therefore, there is a relative minus sign for these things. So what you can do is either you can systematically look at this term here, evaluate its matrix element, ultimately you will get 2 terms with a relative minus sign between them, or you can look at these 2 Feynman diagrams here, compute the amplitudes in the usual way, and then you add them with a relative minus sign between these 2 amplitudes to compute the full amplitude for this process A minus plus A minus going to A minus plus A minus, and then this origin of relative minus sign is here because of the fact that these operators actually anti-commute instead of commuting with each other. Okay, so there will be other processes which arising from this term of the S matrix. I will not discuss them in any detail anymore. So I think you can work them out. Or Or maybe what I will do is that I will discuss this process here, E minus plus E plus going to E minus plus E plus. The Fineman diagram for this process is so E minus E plus, there is an incoming, so this represents an incoming positron, this represents an incoming electron, and then they exchange a virtual photon, and then you have an outgoing electron and outgoing positron. So this is a possibility. This is also a possibility. You have an incoming electron and you have an incoming positron. Okay. They annihilate, produce a virtual photon, and then this virtual photon goes into an outgoing electron and an outgoing positron. So this is also a possibility. You can see both these possibilities from the S matrix here, and then the amplitude here will be sum of these two terms. There is no identical particle here, no identical incoming or outgoing particles, so you need not worry about the exchange term here anymore. So what are the other terms in the S matrix? You have this term which gamma mu A mu of x1 psi of x1 psi bar of x1 psi bar of x2 gamma nu A mu of x2 psi of x2, where psi of x1 contracts with psi bar of x1 and A mu of x1 contracts with A mu of x2. So if you look at S24, there will be two such terms. After changing this domain variable, they will be equal. So this is the term here. So what does it represent? It basically says that there is a fermion propagator and there is a photon propagator here, and then you can have one incoming electron and one outgoing electron, or one incoming positron and one outgoing positron. So picture really what, so this can be written as this electron. So this term represents the electron self energy. This is what is known as the an incoming electron can emit a virtual photon which it can subsequently absorb and then result in an outgoing electron. The same thing might happen for a positron. So this is the physical process that is described by this term in the S matrix. Finally, there is this term which I denote as S25, which is minus E square over 2 d square x d4 x1 d4 x2 and normal order product of psi bar of x1 gamma alpha a alpha x1 psi x2 psi bar x2 gamma beta a beta x2 psi x2 where all the fermions are contracted. So therefore there are two so there is no outgoing electron or positron at all in this process, because all the psi's and psi bars are contracted with each other, whereas there is one incoming photon and one outgoing photon. So this term represents the photon self energy, and the corresponding Fineman diagram which I can represent is there is an incoming photon, and what can happen is that it can emit a virtual pair of electron and positron, okay, which subsequently can annihilate each other and produce an outgoing photon. So this is what is the Fineman diagram for the which will give a non-vanishing contribution for this term. Ultimately, you have at the end you have S26, where all the fields are contracted with each other. Okay, so there is no outgoing particles or incoming particles at all. So therefore, this term will not give contribution to any physical process where you study scattering or decay of a particle or any such thing. It will just represent a term like this. So all these are contracted, and this is the corresponding Fineman diagram. It will only give a non-zero contribution for this term. Okay, so what we will do in the next lecture is we will look at these physical processes that we have discussed in today's lecture, and then we will explicitly compute the amplitude and then the corresponding cross section for all those processes in the next few lectures. All right.